Hey guys, welcome to Circular Motion PSD series, and today we're gonna go deep into circular motion with 12 PYQs, and these PYQs are unique and each of every topic. So let's start. So the first thing, let's start with circular motion kinematics. Circular motion kinematics. Okay, so the first thing is, let's say this is a circle, and so the whole angle here is 2 pi. Am I right? This thing is 2 pi. And let's say this is the center and this is a radius r. So the circumference is 2 pi r and the area is pi r squared. This I hope you guys all know because sometimes you have to use these things. And then it's that this whole angle right here, this one, is 2 pi in a circle, the whole angle. So when I say, let's say the speed is omega. Omega is, now what is omega? What is alpha? Let's study. And what is theta? So theta is the angular displacement. Omega is angular velocity. Angular velocity. And alpha is angular acceleration. Now what do each of them mean? So angular displacement is how much of the theta angle have you moved. So let's say if 2 pi is the whole circle, so this right here, let's say I start from here. So starting point is also very important in such cases. Let's say this is the center. Then this right here is let's say my starting point. And let's say I have moved theta equals to pi. This means that pi by 2 is the whole circle, so pi is right here. So this is pi. So my theta is pi. Now angular displacement is obvious, right? Now let's go to angular velocity. And remember, angular displacement theta is always less than 2 pi and greater than equal to 0 because it's angular displacement. The starting point, the max you can come is back to your starting point, so your displacement is 0. And it has to be less than 2 pi. Okay, so displacement can be 0 or less than 2 pi because displacement is from this position to this position. So the max displacement is 2 pi. Okay, now what is angular velocity? Angular velocity is how much you move, how much of theta you move every second. So it's omega is d theta by dt. Guys, we're gonna go deep into this with conical pendulum, friction, banking. So just stay tuned. I'm just trying to clear your basics because many questions are asked on basics as well. So just stay tuned, guys. Just don't be like he's teaching such mains level stuff. Just see what I'm teaching. This is very advanced as well, and this is gonna help you guys a lot. Okay, so omega is d theta by dt, and alpha, which is angular acceleration, which is the rate of change of omega, right? It's same as saying that acceleration is alpha, velocity is omega, and displacement is theta. You guys can relate it this way, right? And alpha is d omega by dt, rate of change of omega. So now let's say I said this was moving with omega and alpha equals constant. That is alpha equals 0. Now what does it mean when I say alpha equals 0? So right, let's write down here alpha equals 0 means constant omega. Constant omega means constant angular velocity. Now if I say theta equals to, let's say, pi, and I say omega is pi by 3, find the if I say you number of revolutions per minute, find the number of revolutions per second. Rotations per second. Now this is pi by 3 rotations per second. So if I have moved the pi angle in omega pi by 3 time, this means that my speed or my number of revolutions per minute is, so remember this thing, 2 pi into number of revolutions equals to omega. Now omega was pi by 3. So what did I say? Just remember this one. Omega is equals to 2 pi times the number of revolutions. This is very important. Let's delete this. This is not of any use. Just keep this in mind that omega is equals 2 pi times the number of revolutions. Okay, now let's go to this thing. Now this particle, let's say right here, Let me show you here. So a particle right here has a velocity v this way, and if this is the center, it has a, and the omega is omega. So a relation between velocity and omega is v equals r omega. V equals radius into angular velocity. Right now, so yeah, one more thing is that alpha equals d square theta by dt square. Double derivative of theta will give you alpha. Well, not much useful, but yeah, just keep in mind. Next is v equals r omega. And this, yeah, the velocity is tangential to the point. It's tangential, perpendicularly tangential to point. Okay, and now let's go to centripetal acceleration. Centripetal acceleration. Let's see what it does. Centripetal acceleration. It is responsible for the change in direction. Responsible for change in direction. Yes. So so there are two types of accelerations. One is centripetal and the other one is normal acceleration. So what is the role of centripetal acceleration? Very important. Centripetal acceleration is responsible for the change in direction. So let's say, and it's always towards the center. Centripetal acceleration is towards the center. And the value a acceleration centripetal is v square by r. Here v is the velocity, this velocity, tangential to the point, and r is radius. So v square by r is acceleration centripetal, and this helps to maintain circular motion. It helps to maintain circular motion. Okay. Now let's see. Now let's go into the other type of acceleration. Yeah. So v square by r. Now I told you v equals r omega. Now r square omega square by r. So r omega square is also acceleration centripetal. So acceleration centripetal equals v square by r, also equals to r omega square. Right? Keep this in mind. Very, very important. Okay. So this was a little bit of kinematics, and a lot of questions are asked from this, so don't take it lightly. Now let's come to another thing, which is net force towards the center, right? In a circular motion, just keep this concept, hear this concept very, very properly. Towards the center, in a circular motion, let's say this is a body of mass m moving with a velocity v, omega, v equals r omega, radius r. Keep this in mind that the net force F net towards the center is mv square by r. Why? Because this is mass, net force mass into acceleration centripetal, which is mv square by r. This is always the net force towards the center. Now here's the concept. Let's say this is a circular groove. Circular groove is the one wherein let's say it's like this. So this is a hollow here, and this thing's vertical. This is like a wall, a vertical wall, and on that there's the object like this. So the normal force that the wall, this is a wall right here. Circular groove is a famous problem. I'll show you guys the figure when I do the PYQs. I'll show you guys the figure, so stay tuned till the end. Right? So the normal force n, let's say this is a normal force n towards the center. This normal force, now obviously because this goes in a circular motion, now what is the net force? I just explained mv square by r. The normal force equals to mv square by r. Now the question could be, yeah, so this is a common question. They ask you what is the normal force exerted by the wall in a circular groove where the object is mass m. It's mv square by r. Now a question was asked this way, that what is the graph? Yeah, okay, no. I'll show you guys that in PYQ. Just remember this, okay? Normal force equals mv square by r in a circular groove. Okay, now let's move on to another type of acceleration, which is tangential acceleration. Tangential acceleration, which is represented by AT. Acceleration tangential is dv by dt. Now v was tangential to the point, read this one. So dv by dt is acceleration tangential, not very important. Just remember acceleration tangential equals alpha times r. R alpha, where alpha is angular acceleration. So basically dv by dt equals r times d omega by dt. It's the same thing that we're taking this expression and doing dt on this, right? Yeah. So now let's move on to the next topic, which is, yeah. So if there's a linear velocity changes, so if the linear velocity changes or acceleration tangential exists, then angular acceleration is also d omega by dt. Think of it, right? Try to think of it. The thing which I just said. If the linear velocity changes, so what does it mean? If the linear velocity v changes, this means what? This means there's a angular. This means there's a tangential acceleration. Now at exists, right? If linear velocity changes, acceleration tangential exists, then this means that alpha is also there. That means alpha also exists. So one thing to keep in mind is if this thing exists, then this thing has to be there too. So if there's tangential acceleration, then there is angular acceleration as well. Okay, just keep this in mind. Now let's move on to equations of this thing. Equations of circular motion, kinematics. So the first equation is which, so I just told you, right? Displacement is theta, velocity is omega, acceleration is alpha. And yeah, remember this, right? Net force towards the center, which is centripetal force. Yeah, this net force right here is also known as the centripetal force. Centripetal force, which is the net force towards the center when an object is going in circular motion. And here's an application of it, a circular groove. So the normal force by the wall is mv square by r, which is the net force. So the equations of kinematics, just note them down quickly. Theta equals, it's the same thing, like v equals u plus at, ut plus half at square. So ut, let's say omega naught is initial omega, initial into t plus half into alpha into t square. Yeah, it's the same thing, guys. Let's go faster. Omega equals omega naught. V equals u plus at. 1, 2, 3. Omega v square equals u square plus 2 into a into s. S is theta. Right? Keep these three in mind. Now let's move further to, what do you guys want to do? Okay, let's go deeper into this topic, which is a very, very, very important topic in JEE Mains. And I can like not even tell you how many times questions are asked from these topics. Like if you, so all you need for physics is a good teacher and someone who can explain you all the concepts along with PYQs in a way you understand. That's it. You're done. You can get any question right. It's not that hard. Trust me. Okay, now let's go into understanding of what is the net acceleration. So this is circular motion. This is acceleration tangential. This is acceleration centripetal. So the net acceleration equals, now because acceleration tangential is perpendicular to the radius, so these two, tangential and centripetal, are perpendicular to each other, and centripetal is v square by r, tangential is dv by dt. So I can say that net is ac square plus at square, the root of this, which is v square by r square of this plus dv by dt square, and the root of this. Okay, so just keep this in mind, a small concept. Now let's go into, right, so now comes the more important part, which is time period and omega. So if I tell you the time period of something, let's say a circle is something, that is, time period is basically the time taken to complete one revolution. To complete one revolution. So a lot of times they ask this, that if the time period is given and you're given that 2 pi is the whole circle, right? You know this one. Then find the omega. So time period is the time taken to complete one whole revolution. Let's say it's 3 seconds. And 2 pi is the whole circle. So guess what would be the omega? Omega is revolutions per second. So obviously it's 2 pi by the time period, because then if let's say this is 4 seconds, 2 pi is the total circle, then omega is 2 pi by 4, which is pi by 2. So pi by 2 per second. Now let me give you an imagination of how this looks. It's like this. Pi by 2 per second is this. After zero, first second you're here, the second here, third second here, and by the end of the fourth second you have reached back here, right? So it took you 4 seconds to complete 2 pi, because it took you 1 second to complete pi by 2. And remember this: if alpha equals to constant, then this is true. Then this formula omega equals 2 pi by t is true. Otherwise this is not true. Otherwise this is not true. If 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 what if alpha is not constant, keep this in mind. Keep the formula in mind, because I've used this a lot of time in pyq. Trust me. Like, I don't know, like, this is more than 7-8 times I've used this sole thing in pyq. Okay, now let's go into this concept, which is very, very, very important. This is conical pendulum. Yeah, and I love to teach it. Trust me. I love to teach conical pendulum. So let's say, okay, let me write it down. Conical pendulum. So it's basically also, so in the question they don't say conical pendulum. They say that there's a string and it is moving in a horizontal plane. Basically, it's like this. You feeling me? It's like this, right? It's like this. This is the center, and let's say this is length L, and it's moving in a horizontal plane like this. So basically you take a string and you make it move in a horizontal plane this way. This is the dotted line. This is the axis, and this is the radius of that circle in which it's moving. Right, this is the radius. Okay, so now let's say this is theta. After you stretched it theta and then you made it to move in a circular plane, and let's say the tension in the string is T. Let's say T tension. Then you guys are sure that this is theta, right? You guys know this, right? Because opposite angles. So this is theta as well. So this is T cos theta, and this right here will be T sine theta, right? Now, as you know, because this thing is moving in a circle of radius r, the bob, right? This bob right here, it's gonna go this way, like this way, this way, this way, this way, like this. And this is the position of holding, so it's gonna go this way. So now T sine theta is gonna be equal to mv square by r, where v is the velocity and r is the radius. Now you guys know that this is theta, so uh I can say that, wait, so what is the yeah, L sine theta equals to r. You guys know I can say this, right? Because sine theta equals r by L, so L sine theta equals r. Now I can replace r with this, that is, yeah, so first equation is T sine theta equals mb square by r, because I said the net force towards the center in a circular motion is mv square by r. And here this is T cos theta and there's mg downwards, so T cos theta is mg. Now let's use this expression for tan theta, or I could do this way as well. That yeah, 1 second. What else can I do? Yeah, so let's write this as m omega square r, right? So now I can say T sine theta equals m omega square r, which is L sine theta, right? Now sine theta is gone. So basically here I get to know that the omega is uh, T by Lm root of this thing. Tension by length of the string into m is omega, or I can say that the tension is m omega square L. This is the tension in the string. M omega square L, where omega is the angular velocity with which the particle is moving in that circle. And you guys know omega is also v times r, just in case. And but the most important things are this. So equation number 2, equation 3, right? Not this one. equation 4, sorry, equation 2. So these three equations are very important. And now we've come to these conclusions. And now because omega was T by Lm, now let us, go with, uh, yeah, now let me tell you another important concept. So now the important concept that I'm going to teach you is circular turning and banking, right? Okay, give me 1 second. Now let's move on to circular turning and banking. Circular turning and banking. Okay, so let's say this is a road, horizontal road, and there's a car of mass m here moving with the velocity v. This is the radius, let's say, and there's friction as well. Now remember this, in circular turning or banking, friction is the one which provides circular motion. Right, so in horizontal turning, so the better way to write this is that friction helps in circular motion. Okay, yeah, so friction helps in circular motion, and the formula for this is friction gives mv squared by r, which is the net force towards the center required for circular motion. That's it. Now friction is mu s times n, which is mv squared by r. So now you guys know that friction has to be less than equals to mu s n, right? This is the maximum value. So now that I can say mv squared by r is equal to or less than equal to mu s times n, which is m into g. So this is gone. So here is an expression for mu. So mu has to be greater than equal to v squared by rg. Keep this in mind. This is an important formula. Sometimes it's asked that what is the maximum value, or they say, sorry, not the maximum, the minimum value of friction. So it's v squared by rg. Okay, now let's move on from this topic. Let's go to banking of roads. Banking, so banking are of two types. One is without friction, one is with friction. Let's first do without friction, and then we'll go to with friction. So without friction, let's say this is banked at angle theta. Here's a car of mass m. The normal force is this way n, and let's say this one right here is theta. Then this is n cos theta, and this is n sin theta, which provides you the centripetal force. So n cos theta is mg, n sin theta is mv squared by r. So tan theta is v squared by rg. So theta of banking. So theta of banking, which is required to bank. So that is tan inverse of v squared by rg. Theta of banking. This was asked in one of the papers in JEE Main. Important, very, very important. Just the formula is important as well. Okay, so theta equals tan inverse of v squared by rg, where v is the velocity, r is the radius, and g is gravity. Okay, now let's move on to, or you can also say that v equals root rg tan theta. Sometimes they ask you v as well. Okay, now let's go to this thing which is called banking with friction. It's a little complicated, but you must know this thing. Banking with friction. Okay, let's say this is theta, and there's banking as well as friction. So this is mass m. So let's say this is normal force, and sorry, my bad. This is normal force n at an angle theta. So this is n cos theta, this is n sine theta. Now you guys know friction is this way because it's going in a circular path this way, and in order to keep it in the circular path, friction helps. So this is f sine, this is f cos theta obviously, and down here is f sine theta. Right, now the two equations that we can make is f cos theta plus n sine theta, right? F cos theta plus n sine theta is equal to mv square by r, and n cos theta equals f sine theta plus mg. Okay, I hope it's clear. Now let us solve it. So you guys know that friction equals mu times n. Now my goal is to find the max velocity. Let's find v max for this circular motion to happen. The maximum velocity for circular motion to happen. Now when I replace f equals mu n, so I get n cos theta equals mu n sine theta plus mg, and here as well, which gives me, sorry, this is n, this is mu n. Let's make this mu n. Now I took now while solving this equation, I'm gonna take n common, so I get mu cos theta plus sine theta plus mv squared by r, and here I'm getting mg equals n into cos theta minus mu sine theta. Okay, so now what do I replace? Right, so I can replace n right here, which is cos theta minus mu sine theta. Sorry, mg by cos theta minus mu sine theta into mu cos theta plus sine theta will give me mv squared by r. Theta theta, mm is gone. So velocity equals mu cos theta plus sine theta into r by into rg, right, into cos theta minus mu sine theta divided by this and the root of this. So this right here is the maximum velocity, and this we have found after solving these two equations right here, which were after balancing. These were after balancing the vertical and horizontal component, right? Okay, now let's move on to something new, which is, now let's move on to vertical circular motion. Yes, vertical circular motion. So first of all, what is vertical circular motion? And main thing which we use in vertical circular motion is energy conservation. Just wanted to let you guys know that energy conservation. So anytime you see vertical circular motion, do not panic and use energy conservation. It's going to be a piece of cake, right? So let's see. If this is a circle, let's say a guy or a man or a woman or whatever, he's trying to make a vertical circle with this as center and radius r. Obviously radius r in the sense radius l, the length of the string. Let's say he has a string, a bob right here, and he's making a vertical circle of length l. So first of all, let me explain energy conservation before I go into this. Let's say this is a thing, container, and let's say this is radius r. This is a hemisphere, and here it was rest initially, and now somewhere here it is right here, and this is the normal force. This right here is mg, and this is the velocity v of it. Okay, and this is the reference position. I'm taking this as reference position. Then, first of all, here mg is a conservative force, and normal is external force. Therefore, work done by external force equals F dot V cos theta, which is 0. I hope you guys got this work, power, energy right. We studied that if work done by external force, which is force into velocity, work done, is force V cos theta, which is 0 here because velocity cos theta is 0. And so we can say that the work done by external force is 0, therefore energy conservation works here. So this is the proof why I have used energy conservation, because work done by external force is 0. Okay, now let's go into this. So yeah, so right here, and right here. So what is the R? So you're down by R, and at the top it was in at rest. So energy conservation states that Ui plus Ki, initial kinetic plus potential, equals Uf plus Kf, and this is called energy conservation. And we are going to use this in circular motion as well. So very important. So now for this case, at the top point, which is right here, the potential, because this is reference. This is why I defined the reference before itself. Reference is very important. So this right here is the reference, right? So this is reference. From the reference, this is at a height r. So mgr is the initial potential, and kinetic was 0 because it was at rest initially. Down, because this is reference, uf is 0, and this is all half mv square. So I can say that mm is gone, v equals root 2gr. It's basically like a free fall motion, guys. How tough is it? So this right here is root 2gr, the velocity at the bottom. When you go down by r right here, right, the velocity here is root 2gr. Just wanted to, show you guys what conservation of energy looks like. Because now comes the actual explanation of it. And let's say they could even ask you a question saying acceleration centripetal at the bottom. What is it? So it's v square by r, and here r is r, and v square, v was root 2gr, so it becomes 2gr by r. So the velocity acceleration at centripetal, which is towards the center, ac, equals 2g. Right? Keep this in mind. I think I saw a question of this way in BitSat or something, but just to let you guys know. Okay, now let's go to vertical circular motion. Wait, let me write this here. Velocity equals root 2gr at bottom. Okay, so in a vertical circular motion, now let's go deep into vertical circular motion. I hope you guys understood this one. This is what this is, energy conservation. Now in vertical is now in circular. Sorry, now in vertical circular motion. So here, the normal force at the bottom, tension at the bottom. This is all we're gonna discuss. Okay, so let me go. Okay, do you guys want me to go deep into this one, because this could be asked as well? But I don't find the need. I've gone a lot deep. Told you the acceleration. Okay, let's find the normal force at the bottom. Normal force. Okay, let's actually go deep. It's okay. There's nothing I'm gonna lose going deep. So if this is this thing here, it was at rest. This is reference. So here it was mgr ui, vi was 0, half mv square, 0. So v was root 2gr. At the bottom, the velocity is root 2gr. Towards the center, let's say this is the center. My ACR was 2g because AC is v square by r, and 2gr by r, which is 2g. Now if I say normal force at bottom, so what is the normal force at bottom? The normal force at bottom is the net force, which is mv square by r, which is mg minus, guess what, mg minus normal force. Sorry, normal force minus mg. So the normal force is mv square by r plus mg. Now you guys know this right here, mv square by r, which is acceleration centripetal plus mg. So 3 mg is my, now this can be written as a into ac, m into ac. So m into AC, which is 3 mg. So one important thing is that normal at bottom is equal to 3m into g, right? Okay, now let's go to vertical circular motion. Now I'm going to completely start vertical circular motion and no more heading here and there. So if this is a circle, so this is length L of the string, which is, so the trajectory is this way, like this, like this, like this, like this, like this, like this, right? So now, so there must be a minimum and a velocity with which it has to be given so that it can pass each point. Now, the minimum velocity at the bottom, okay, is root GL. Here it's root 3GL. Here it's root 5GL. Here it's root 3GL. I guess this is something you guys should remember. And if you guys want, I can give you guys the proof as well. So let's start. So if this is L, this is L. This whole height is 2L. Let's use ui plus ki equals uf plus kf. And now 0 plus half mv square, because this is reference started from here, which is equals to uf, which is mg into 2l plus kf, which is also, so there's a kf as well, don't say it's at rest, it's half mv square, so that is half mu square, right? So u is the velocity here, u, and v is the velocity here, v. Now, so I can say that u square equals 4gl plus b square. This is the first equation, right? From this. Now the second equation, think of it. I told you guys what to do. Net force F net equals to mv squared by r. Use this thing. So as soon as you guys use this thing, you're gonna get T minus mg, tension minus mg will give you mu squared by L, which is right here. Tension is the tension in the string. Yeah, don't forget this. There's a tension in the string as well right here, and there's tension here as well. This is T1, this is T2. Or let's say tension at bottom, tension at top, right? So the tension at, so this equation is by energy conservation, the first one, which is half mu square equals this. Second one is by F net equals mv square by r. So tension, which is upwards, mg, which is downwards. So tension minus mg will give you an F net, which is mu square by L, which is centripetal force. Now, okay, this is the equation number 2. Equation number 3 is at the top, which is tension 2, which is in the bottom. So this is how it looks like. Below is tension 2, here is mg, whereas for the bottom it's tension 1 above, mg downwards, f centripetal, f centripetal, right? So tension 2 plus mg equals to mv square by L, because here the velocity is v, here the velocity is u, right? This is a very detailed explanation, so I hope it's clear to you guys, because circular motion, vertical circular motion, is very, very important. So I just don't want to miss anything, because later on I don't want you guys to cut any marks in this, because this is one of the easiest. Okay, and now let's solve these equations. So solving in the sense, don't sit and like start to find common solutions. Here what you have to do is think of it. If I'm saying for u to be minimum, right? My goal is to make u is minimum. Now let's go to the equation where I see u. So for u to be minimum, right? For u to be minimum, v also has to be minimum. Am I right? 4gl is constant, right? This is constant. 4gl is constant. Now let's go to this thing. Now for v to be minimum, I can say tension 2 right here has to be minimum. And you know tension can be 0, so it has to be 0. Now to make tension to 0, I can say that the string. So basically, some people have a question now: if tension 2 becomes 0, won't the string slag? Well, it won't slack, because there's a certain amount of velocity at the top, which will make it to regain its shape once you go down from that point. So it won't necessarily slack. Actually, it won't even slack, and that is the reality. That's why I'm taking tension to be 0. Now I can say if tension 2 is 0, mg equals mv squared by L. So V is root GL. Therefore V, which is root GL, is the minimum U. Sorry, minimum V max. That is V at the top is root GL, which is the max minimum V. Sorry, minimum. What am I saying? This is the minimum V. Now the same way let's find for the bottom, which is U minimum, which is this thing. Now this formula, 4GL U minimum square equals 4GL plus GL, which is root 5GL. Therefore, the U minimum right here, right? So U minimum is root 5GL, and V minimum is this, and U minimum is this. Okay, now we're gonna head to the PYQs real quick. Here you go. Here's the PYQs. So stay connected and don't go. Or do you actually? I'm gonna do the PYQs in a new video. I'm gonna stop this one. This was pure explanation of every single topic in depth. PYQs is in a new video. Okay, let's quickly finish this. So yeah, right. So now I'm done with everything with minimum velocity, which is 5GL root 3GL. Yeah, velocity is here is root 3GL and 3GL. Root 3GL root 3GL. The minimum velocity here at these points. Okay, now let's go to tensions, right? So tension. Now let's look at tension 1 and tension 2. So wait, where was I? Yeah, tension 1 is this, and tension 2 is this. Let's write it here. So tension at the bottom was mv squared by L plus mg, and tension at the top was mv squared by L minus mg. This was mu squared. So from this we can say one thing, that tension at the bottom is greater than tension at the top, right? I hope you guys know we can say this. Tension at the bottom is greater than the tension at the top. And now, and another thing is that the maximum tension anywhere at any point in the vertical circle is tension at the bottom, and the minimum tension is the tension at the top. Right? This is a golden line, I'm telling you. Keep this in mind. Tension at the top is the minimum, tension at the bottom is the maximum. Now you guys see the expressions for tension bottom, tension minimum. Just substitute U and V here and find the tensions. Minimum tension and maximum tension, obviously. So tension at the bottom, which is U was root 5GL, so 5GL by L plus mg. LL is gone. 6 mg is my maximum tension, and tension bottom, tension top, which is minimum tension, is mgl by L plus m minus mg, which is 0, right? So tension at, oh wait, did I mess up? Yeah, probably I did mess up. No, I'm right. Yeah, tension at the top, the minimum tension is 0, and the maximum tension at the bottom is 6 mg. Okay, so I hope it was clear to you guys. This was a detailed explanation of vertical circular motion, and the PYQs. You guys can check out the video which I've put down in the description, or go to the channel and check out the circular motion PYQs. I'm going to be covering like 15 to 16 PYQs which are here. So see you guys later. Bye.